Just watch movies and there's some crazy scientist who's made some super acid that's going to eat through the world or whatever. The acid that they pull out for the special effects in that is usually going to be nitric acid. And the reason is that nitric acid is incredibly reactive and it will eat through pretty much any metal other than gold and platinum. And so for movies, special effects, eating through the table and stuff, this one is great. It's actually not just because it's a strong acid. Nitric acid is also a very strong oxidizing agent, which is something that I'm going to tell you guys about when you all sign up for Chemistry 12 next year. So in addition to being a very potent acid, it's also a very potent oxidizing agent, which is also why it's used to make a bunch of explosives and stuff. So that's another cool thing. So what we're going to do is very illegal. It is actually against the law to destroy money, but I'm going to do it anyways. Because we've stopped making pennies in Canada, pretty soon all your prices will be rounded off to the nearest nickel anyways, so who cares? Breaking the law, don't tell anyone. Yeah, that's why we're posting the video. Okay, so nitric acid happens to react in a visually exciting way with copper. I'm going to turn the fan on here. And what we're doing is eating through the copper and we're making a solution of copper nitrate in the bottom. And that's the bluish green stuff in there. The gas that's coming off is nitrogen dioxide. And this is the stuff that makes LA look gross. Anybody ever been to LA? Okay. This is smog. This is way more concentrated than LA. But this is the stuff that gives big cities the brownish orange hue and stuff. There's some pretty sunsets. But it's not very good for you. It's a choking gas. If I didn't have the fume hood on, anybody took a whiff of it, you'd be on the ground. So we're just throwing it up out of the ceiling, and right now people in the computer lab are feeling a little lightheaded. So talking about battery acid in your Duracell isn't just a little bit wrong, it's the complete opposite. Okay, there isn't any acid, there's a base in there. But car batteries have sulphuric acid in them. And sulphuric acid is a very strong acid, and one of the things that acids want to do is they want to break apart into their ions. They want to dissolve in water. And sulphuric acid wants to dissolve in water so badly that if you were to take the lid off of this and just leave it open, right, and you take a look at the volume that's in here right now, instead of the sulphuric acid evaporating away, over the next few days, you'd see that the level would actually climb in here. And what it's doing is it's sucking the water out of the air because it wants to dissolve so badly. And so sulphuric acid is known as a desiccant. And so if you need to keep chemicals dry, you put them in a room with sulphuric acid, open the container, and that'll suck all the water out of the room to keep those other chemicals dry. Sulphuric acid wants to dissolve so bad that if there isn't water there, but there's a way of making it, it'll make water so that it can dissolve. And that makes it dangerous. So, sugar. It's the formula for sugar. C6H12O6. Let's take a look at the ratios. H12O6. What is the ratio of hydrogen to oxygen? 2 to 1. What is the ratio of water? 2 to 1. So, do you think sugar might be a good thing for sulphuric acid to try to get water out of? Yeah. So what sulphuric acid is going to do is it's going to react and it's going to make water. When it pulls the H12O6 out of the sugar, what's left behind? C6. And so we're going to have water with acid dissolved in it and carbon, pure carbon. We're going to fast forward this because it takes 2 or 3 minutes to go to completion. But it's still pretty cool. Now, sulphuric acid is nasty stuff without your body's not made of copper, right? So we're not worried about the nitric acid, like that copper chemicals. But what is a big proportion of your cells made from? Water and carbohydrates. Okay? So your cells have lots of water and have lots of carbohydrates. You think that sulfuric acid might like to react with your body? And there are actually cases of people using battery acid as a weapon, so taking it out of car batteries and splashing it on people's faces. And you don't just get, a red face, which would be a first-degree burn. You don't just get blisters, which would be a second-degree burn. It actually chars your face, or your skin, that people have to be throwing it on faces. And so you're turning bits of your skin into carbon exactly the same way that would happen if you didn't just put your hand on the flame and pull it out, but you put it in and you left it there for 45 seconds or so. So third-degree chemical burns, it chars. Now, we're making a lot of heat as well. What happens to water as it heats up? Turns into, so it boils, turns into a gas. What do we know about the volume of a gas compared to a solid? It's bigger. So what's happening is we're making large bubbles of steam, and around them a shell of carbon is forming. So we're making kind of a cast of those bubbles, and they take up a lot more space than the sugar. And so this is acid-coated carbon. If I turn the fan off, it'll smell like burnt marshmallows. Let's get wet. It smells like burnt marshmallows. And it's crispy. It is like charcoal. Okay?